All right, hi folks, this is Larry Mussolino. I'm recording a video for STAT412. This is module 9, and I wanted to go through a few homework problems from the MyLab homework, and also wanted to go over a few using an Excel spreadsheet to help with hypothesis testing. So here in module 9, we really want to look at hypothesis testing comparing two proportions. You know, a proportion is like a percentage, how many out of the total. Maybe I want to compare the percentage of smokers for males versus females. Maybe I want to compare the SAT scores for seniors versus juniors at a high school. So these are all examples where we want to compare two proportions. So the basic setup is we're going to take one sample and record the number of successes and the number of observations. Same thing for sample 2. And then this calculator is going to give you the test statistic and the p-value. The p-value will depend on whether the alternative has a less than symbol, greater than symbol, or not equal symbol. Some questions ask you to calculate a confidence interval. So here's going to be the lower and upper bounds of the confidence interval that you're interested in. Okay? So let's do some examples to get started. Let's come here at for question 1. And it says, we want to study the proportion of residents in city who favor construction of a nuclear power plant. So it looks like for urban, in an urban area, 54 out of 80 say they're in favor. And in suburban, a suburban location, it looks like 49 out of 80 are in favor. Okay. Is there a significant difference between the proportions? Now, when I see the word difference, and remember, you have 3 possibilities for setting up the null and alternative. When you set up the null and alternative, the alternative can either have a less than or a greater than or not equal symbol. So what I want to do is read the problem carefully and see if there's any indication that the claim involves a less than sign, greater than sign, or a not equal sign. Well, the word difference, you know, if something's different, it's not equals. So in this case, when they use the word difference, we're going to use a not equal symbol. So here's going to be the setup of the null and alternative. All right, well, I want to know the test statistic and the p-value. So I'm going to come to this calculator. And remember, in these calculators, you only enter data in the yellow boxes, and the results are given to you in the green boxes. So let me come over here to this first yellow box. This is going to be the urban location, 54 successes out of 80 people I asked. Let me come down here to suburban schools. 49 people said yes out of 80 I asked. Okay, well, here is the test statistic. By the way, here is the proportion for sample 1. So 67.5% in urban said they're in favor. And here's sample proportion 2. 61.25% of people in a suburban location are in favor. All right, well, here's the test statistic, 0.825. My math lab wants us to round to 2 places, so I'm going to enter 0.83 for my answer. All right, now, remember, our alternative had a not equal symbol. So I'm going to come over here to this p-value because we're using a not equal symbol in the alternative. I'm seeing the p-value is 0.409. Okay, so here it is, 0.409. My math lab has a little bit of a tolerance built in. The reason there's a little bit of a tolerance here is because you get a slightly different answer if you use these lookup tables versus using Excel. So if I click here, you'll notice there is an answer tolerance built in here for us. All right, let me come down here. So what's our conclusion then? Well, for us, the p-value is 0.409. Our alpha was not given, so we're going to use 0.05 as a kind of a default value. Well, 0.409 is greater than 0.05. So here's my my decision. If the p-value is greater than alpha, do not fail to reject the null hypothesis. So we're going to say do not reject the null hypothesis. If you come down here to fail to reject, notice it says there's not enough evidence. So there's not a significant difference between these proportions. Okay. And then it says, in general, the null hypothesis is rejected for significance levels greater than p-value. Well, we have it written a little backwards here. We say if the p-value is less than alpha, you reject the null. That means, same as saying if alpha is greater than the p-value, you reject the null. Okay, so we would say for alpha, remember alpha is the same as the significance level. If that's greater than the p-value, we're rejecting the null hypothesis. That's the same as saying if the p-value is less than alpha, reject the null hypothesis. All right, so let's take a look at another one. All right, let's come here to number 2. This one says, looks like there's a study on fertility of married women. We took 2 groups, 263, so let's call this group 1. 263 out of 350 plan to have children. Let's go to group 2, 269 out of 400. So this is comparing, I guess, folks that were married 2 years versus 5 years. So here's the question. Can you conclude the proportion married less than 2 years is significantly higher than the proportion married 5 years? Well, the word higher means greater than. So I'm going to be using greater than in the alternative. So this is my choice for the setup of the null and alternative. All right, let me come over to Excel. Group 1 was 263 out of 350. Group 2 was 269 out of 400. And let me come over to the test statistic. I'm seeing the test statistic is 2.37 here. And our p-value is a greater than symbol. So I'm going to be using this p-value here, 0.009. Okay, so we have the test statistic, we have the p-value. Excel is giving that to us. Let me scroll down here. All right, we need to know what is our decision. Well, for this example, our p-value was 0.009. Again, they didn't give us a value for alpha here, so we're going to assume 0.05. Well, this p-value is less than alpha. If the p-value is less than alpha, our decision is going to be reject the null. And if we reject the null, there is enough evidence to reject this hypothesis. So reject the null. There is sufficient evidence to reject the hypothesis. All right, so again, this Excel calculator will calculate the test statistic and p-value for you. So please, check out this calculator. I'm going to post this in course announcements, so you'll have a copy available there. All right, let's take a look at, let's see if there's anything here a little different. Let's come here. I guess we do this one. Let's do this one. It says, this is talking about people challenging referee calls. It says men challenged 1402 calls and 420 of them were overturned. For women, they challenged 751 and 210 were challenged. Use 0.05 significance level. So they're telling us to use alpha equal 0.05 here. And test the claim that men and women have equal success. Well, equal success means we want to use an equal sign for the null, and the complement of equal is not equal. So we're going to use this setup right here. All right, so let me go and enter this into the Excel calculator. So let's see, for men, it was 423 out of 1402. For women, it was 210 out of 751. All right, let me come and get the test statistic. Here it is, 1.07. Let's get the p-value. Remember, this was a not equals in the alternative. Well, here is the p-value to use if you're using a not equals in the alternative, 0.284. So there's the p-value. All right, what's our conclusion? So our conclusion here is our p-value was 0.284. We're going to use a value for alpha of 0.05. Well, definitely this p-value is greater than alpha. If the p-value is greater than alpha, fail to reject the null hypothesis. So here's our conclusion. The p-value is greater than the significance level of 0.05. Fail to reject. And when you fail to reject, there's not enough evidence to warrant rejection of the claim. All right. Well, now they're asking us a part B to this question. Part B says, test of the claim by constructing a confidence interval. So what we're going to do here is come up with a 95% confidence interval. And once we have that confidence interval assembled, we can come to a conclusion just like we did in the hypothesis test. But instead of using the hypothesis test as the basis, we can use a confidence interval as a basis. I'll explain more about that in a second. First, let's calculate a 95% confidence interval. Well, I'm going to come down here to this section of the calculator. It says use this section for confidence intervals. The first thing I have to do is enter the confidence level that they're asking me about. Well, in this case, they said 95%. So for 95% confidence, I'm going to enter it as a decimal of 0.95 in this yellow box. So let me change this box to be 0.95. That matches the 95% confidence interval. And here is the lower bound, negative 0.18, and here's the upper bound, 0.062. So I know the confidence interval, here it is, lower and upper bound. All right, well, really what this confidence interval is, it's a confidence interval around the difference P1 minus P2. Now here's what I'd like to know. Let me graph this on the number line. Here is the lower bound at negative 0.018, and here's the upper bound at 0.062. I want to know, does this confidence interval include 0? Well, yes, it does. 0 is right here in the middle somewhere. So 0 is included. Let me write that down because that's going to be important. 0 is included in the confidence interval. Well, what does that mean? Well, remember, this is a interval for the difference P1 minus P2. Let's say it was equal to 0, for example. If the difference was equal to 0, that's the same as saying P1 equals P2. Right? If I have P1 minus P2 equals 0, I can just add P2 to both sides of this equation algebraically, and that would get me P1 equals P2. Well, that's saying the proportions are really the same. That would say if the proportions are the same, between men and women, that would tell me that there's really not a significant difference. And if I look at the actual proportions for males, for men, it was about 30% of the calls. For women, it was about 28%. So that's telling me that these two percentages are so close together, there's really not a significant difference. So here's my conclusion. Because the confidence interval limits include 0, there does not appear to be a significant difference. There's not enough evidence to reject the claim. So it's the same answer we got from the hypothesis test. It's just we use the confidence interval analysis to come to the conclusion. Okay? And I think a good way to think about it is ask yourself, is 0 part of the interval? If the confidence interval does include 0, so if here's the lower bound and here's the upper bound, and 0 is in the middle, that must mean, this is a negative number and this is a positive number. If that's the case, you can conclude that P1 minus P2 might equal 0. And that's the same as saying P1 equals P2, which would mean there's no significant difference between the two proportions. Okay. And let me scroll down. I guess there's one more question here. And our conclusion was the confidence interval is suggesting there's no significant difference between men and women when it comes to challenging these calls in tennis. All right, so we can either use the confidence interval method or hypothesis testing method. You should end up with the same answer for either method. All right, maybe let's do another one. This one I think is similar. So yes, let's do this one. All right, let's take a look at this one. It says, study was conducted to determine the percentage of the proportion of people who dream in black and white versus color. For let's see, over 55, 79 out of 314 dream in color. Excuse me, dream in black and white. And I guess under the age of 25, 15 out of 304 dream in black and white. All right. Use 0.05, so alpha is 0.05 significance level, to test the claim that the proportion of people over 5 is greater than the proportion under 25. Well, if it's greater, we're going to be using this setup here with a greater than in the alternative. All right, so let me come over here to Excel, enter in the data. This is the over 55 crowd, 79 over 314, under 25, 15 out of 304. Okay, let's come over here to the test statistic. Test statistic is 6.999. We'll round that to 7. And the p-value, now notice this is a greater than symbol in the alternative. So I'm going to be coming to this row here, and it looks like the p-value is 0. Well, if the p-value is 0, that's definitely less than alpha of 0.05. Well, if the p-value is 0, less than alpha 0.5, if the p-value is less than alpha, reject the null hypothesis. So our decision here is reject the null hypothesis. All right, let's scroll down. What's the conclusion? Well, we just determined, I guess I'll erase some of this stuff. Well, we just determined that the p-value was less than alpha, so reject the null hypothesis. And when you reject the null hypothesis, there's enough evidence to reject the claim. So there's enough evidence to either reject or support the claim. Now they want a 90% confidence interval. So I'm going to come over here to this confidence interval calculator, enter 90% here, 0.90 in decimal. And the lower bound of the confidence interval is 0.157. The upper limit is 0.247. Let me graph this on a number line just to see what's going on. Here's the lower bound of 0.157. Here's the upper bound of 0.247. Notice this does not contain 0. 0 is back here somewhere. So our interval here, our confidence interval, does not include 0. Remember, P1 minus P2 is the confidence interval we're including. If P1 minus P2 was equal to 0, then we'd be saying there's really no significant difference. But if P1 minus P2 is equal to some number in the middle here, there is a significant difference. So these proportions are not equal. So because the confidence interval limits do not include 0, two proportions are not equal. Because the confidence interval only includes positive values, it looks like the proportion of people over 55 is greater, right? Because this is going to be a positive number. For that to be positive, P1 would have to be greater than P2. P1 was the proportion for people 55. And we'll scroll down to do one last part of this. So our conclusion is No, there is a difference between these proportions who dream in black and white. All right. Let's see here. Let's take a look at this one. All right, folks, let's look here at one more. It says, we took a random sample of front seatbelt occupants in car crashes. There were 2,972 occupants not wearing seatbelts, 39 were killed. For 7,802 wearing seatbelts, 12 were killed. Use a 0.05 significance level to test the claim that seatbelts are effective. All right, so I got to be a little careful here about reading what the setup is here. So I'm going to use P1 to mean that it's the proportion of, let's read here. It says, consider the first sample to be the sample of occupants not wearing seatbelts. So P1 is not wearing seatbelts. And according to the data they gave us, 2,972, 39 were killed. The second sample is going to be the people wearing seatbelts. So P2 is those wearing seatbelts. And for that, they're telling us 12 were killed out of 7,802. Use alpha equal 0.05 to test the claim that seatbelts are effective in reducing fatalities. Well, if seatbelts really are effective, then we would expect P2 to be less than P1, right? Because the proportion would be lower if you're wearing a seatbelt. Well, that's the same as saying P1 is greater than P2, right? It would mean the proportion of people getting killed is greater if you're not wearing a seatbelt. That assumes the seatbelts are effective. So I'm going to be using this setup here saying P1 greater than P2. All right, so let me come here to the Excel calculator. For our first group, it was 39 killed out of 2,972 not wearing seatbelt. For the second group, 12 were killed out of 7,802 that were wearing seatbelt. All right, so it looks like the test statistic is here, 7.83. For us, our alternative is greater than symbol. So we're going to come here, the alternative is greater than symbol. It looks like our p-value is 0. All right, well, we can come to a conclusion. Our p-value is 0. They told us to use alpha equal 0.05. Well, the p-value is less than alpha. If the p-value is less than alpha, our decision here is going to be reject the null hypothesis. So we're going to reject the null. So let's scroll down. Let me clear this. All right, we're scrolling down here. All right, so they're asking us, what's the conclusion? Well, our p-value is less than alpha, so reject. There is enough evidence, there is sufficient evidence to support the claim that there's a higher fatality rate for not wearing seatbelts. All right, let's do a confidence interval. Now, I got to be careful on this one because they're not giving me a confidence level here, right? It says construct a confidence interval, but they're not giving me a confidence level. So I'm going to have to figure that out ourselves. Well, we know 0.05 is the significance level. Well, this test was a one-tailed test, right? It was a greater than sign. So what I'm going to think about is putting this alpha 0.05 in either side of the normal distribution. And this area inside here is 90%. So we're really going to be constructing a 90% confidence interval for this one. So they didn't tell me that, but I had to figure that out myself by knowing the value of alpha. All right, well, let me go ahead and enter 0.90 here. and the confidence level. And it looks like I'm coming up with the lower bound of 0.008 and the upper bound, here it is, 0.008. The upper bound is 0.015. Well, if I think about that on a number line, the lower bound is 0.008 and the upper bound is 0.15. Well, this does not include 0, right? 0 would be back here. So the confidence interval limits do not include 0. Remember, if P1 minus P2 is equal to 0, would be saying the two proportions are the same. But our P1 minus P2 is not equal, doesn't include 0. That must mean the two proportions are not equal. And because the confidence interval only is positive, it looks like the fatality rate is higher for those not wearing seatbelts. You can kind of see it here. This proportion, this was not wearing seatbelts. Right? The proportion was like 1% killed. Here's the proportion wearing seatbelts. Well, that's like 0.15%. So definitely it looks like the data is telling us that the proportion of people getting killed not wearing seatbelts is much higher than proportion getting killed wearing seatbelts. So here's our conclusion. The results suggest using seatbelts gets you lower fatality rates than not using seatbelts. Okay, folks, I think most of these questions are going to be very similar here in terms of asking for a test statistic, p-value, use this rule here to come to a decision. Some questions might ask you about confidence intervals, use the confidence interval calculator here. And I hope this is helpful as you're working in the Module 9 homework.